when we think brain, we're just always thinking, uh, memory, or the one that helps us remember. We're just always only thinking of this one, the cerebrum. But you see, the brain begins with this one. For your lab exam, if there is this one right here, this stalk, that is your spinal cord, okay? If there's a pin sticking out like that, so and then I ask identify, you're going to say spinal cord. If there is a pin sticking out like that, then you're going to identify it as the parts of the brain. You understand? I hope you don't forget. If the pin is that way, spinal cord. If the pin is, so in other words, this is your brain. This annoying. Oh, sorry. There, see? So there will be a pin sticking that way, so you're going to say spinal cord. If it's that way, you're going to say medulla, you're going to say pons. Okay? So now let's study the brain. The first part of the brain is the medulla. Okay? Don't forget, okay? On Thursday next week, May 26, we're going to have our lecture test up to this one. Everything that we're going to study today. And like I said, next week there's nothing in our schedule for a test. We're just going to have our test then. Okay. So, first part. Oh, hi, you made it. I sent you a message. So here is, so the first part right here is the medulla. This is the most inferior part of the brain. This is brain. From here up, this is brain. Okay. The first bulge that you will see is medulla. You will see that in your sheep brain. It's very easy to identify it. Next to medulla, what are you going to write? You're going to write number 1, crossing over, or decussation, right here. Decussation. We're looking at the functions of the different part of the brain. This is where fibers cross over. This is why when you have a stroke on the right side, you look for left brain problems, right? And on the left, you look for right brain problems. Because of the medulla, they cross over. You understand? Next to medulla, you're also going to write cardiovascular center, heart and lungs. See? It has the cardiac center, the blood vessels. So it's the one that regulates your heart rate, it controls your heart, and also the respiratory center. So it's the one that regulates your breathing, your respiratory rate. Okay? So if you have problems with the medulla, you're going to have heart problems, breathing problems. It's the one that tells you to breathe. Okay? Next to medulla, you're going to also write, this is where you'll find the origin of cranial nerve number 8 all the way to 12. 8, 9, 10, 11, 12. Have you heard of neurological assessment, neurological testing? When you get to the nursing program, that's the first thing. Always, the students come back to me and they always say that's the first skill that they do there, which we do here already. What's the importance of doing neurological testing? Because you know where they originate, you see? You test for 8, 9, 10, 11, 12, and if it's all abnormal, you suspect problem in the medulla because you know that's where it started. Okay? Next, we're going up, the pons. The next bulge is called the pons. I'm going to go back to this picture over here. Here, see? The first bulge is the medulla. The next bulge is the pons. Next to the pons, you're going to write bridge. This pons is the one that bridges the cerebellum to the rest of the brain. Okay? And then, also next to the pons, write lungs. It helps. It helps the medulla. It modifies your respiration. In other words, the medulla sets your breathing rate. Let's say you breathe 20 times a minute. But you know, breathing involves inhale, exhale. How long you inhale and how long you exhale is regulated by your pons. So if your pons is damaged, you will still breathe. If the medulla is damaged, it stops breathing. You understand? Okay? That's the function of your pons. And then, next to pons, write cranial nerve 5 to 8. That's where they originate, 5, 6, 7, 8. Okay?
Did you say cranial nerves?
Cranial nerves, yes. Then we're going up. I'm going to go back to this picture over here. Up here, so we studied the medulla, the pons, and then here. This is your midbrain or mesencephalon. Midbrain is easier to remember. Midbrain. So when you get your sheep brain, you know this is stuck in there. So you have to pull this open so you can see your midbrain. It's made up of 4 like pea-sized circular structures, and you'll see that on Tuesday when you do your brain dissection. Okay? Next to midbrain, you're going to write auditory and visual reflexes. Auditory, right here. Auditory and visual reflexes. So that's where you'll find those 4 circular structures. They're called colliculi. So you know it's in here, in our model right here. See, there's your medulla, there's your pons, and the midbrain is right in there. Okay? I'll show you that when we do our dissection of the sheep. Next to midbrain, also write cranial nerve number 3 and 4. This is where cranial nerve number 3 and 4 originate. So what does it mean by auditory and visual reflexes? You know when you see or hear a loud explosion and you go, all of those reflex reactions that happen to you, that's because you have a functioning midbrain. You understand? Okay? Now, with this medulla, pons, and midbrain, you make a bracket and you write, they make up the brain stem. Brain stem. So you see, it's like a stem, and there's a flower. The brain is like the whole flower. So this makes up the brain stem. And within this brain stem, meaning the medulla, the pons, and the midbrain, there's scattered nuclei. Nuclei of your neurons. And they make up what you call the reticular activating system. Have you heard of that? Reticular activating system. Right here. Okay? This is your wakefulness. See, it wakes you up from your sleep. There's the difference between sleep and coma. Sleep is temporary loss of consciousness. Coma is permanent loss of consciousness. So you woke up this morning because your RAS is working. You heard the alarm clock and you woke up. Where is the RAS, the reticular activating? In the brainstem, right? With medulla, the pons, and the midbrain. Scattered nuclei there. They function as your reticular activating system. So if this gets damaged, you will go into a coma. But the headquarters, see, the headquarters of the RAS is in your midbrain. And if you look at this brain right here, look at your midbrain, thankfully, is stuck all the way in there. So this is how it sits, right? So sometimes, you heard, you know the terrorists, they're trained to aim for the neck. And the reason is because that's where you see, the base of the neck is where you have your brainstem. But thankfully, your midbrain is stuck all the way in there. So, because this is the headquarters, I'm sure you've heard of some stories sometimes where person goes into a coma, then a few months later, the person wakes up. So maybe the midbrain was not affected. Okay, that is where the headquarters is. You understand now the difference between sleep and coma, right? Okay, now we're going up. Now we're going to go to the cerebellum. This is the second largest part of the brain, right here. And this is the cerebellum over here. And very, very distinct, you will see that the cerebellum has, it looks like a cauliflower, has many, many folds. The fold is called folia, and the white matter, okay, you should know now gray matter, white matter. When we open up the brain, you will always see the outer part is gray in color. And the color is because of which part of the neuron you think. Would it be the cell body, dendrites, or axon? The dark color must be because of the what? Very good. The cell body, because that's where the nucleus is, right? Very good. And so you see out here, and it makes sense, right? The cell body is big, right? And then the axon is just like that. So the cell body is always outside, and then the axon. It's like a bunch of balloons. You can hold 100 balloons, like this, the string. But then you look up, lots of balloons. So how do you accommodate those balloons? You fold them. So that's why it looks like this, okay? And then the white is referred to as the tree of life, the arbor vitae. The cerebellum is very nosy. It has to know everything that's going on. In fact, they say that the neurons that make up the cerebellum, they call it Purkinje cells. Each neuron has about 250,000 dendrites because it's the one responsible for fine-tuning your movements. You know, your very nice coordinated movement is because of the cerebellum. They say, you know, how do you know where to reach when you're playing badminton or whatever? It's because of your cerebellum. Who has been drunk in this class? Oh, good. I'm not the only one. Okay, if you've ever been drunk, you know how it feels to have your cerebellum damaged. It's called ataxia. Okay? So, similar to being drunk, it's responsible for equilibrium. Okay?
Would it be the same thing at like bridal showers and stuff like that? They play the game where you put your head on the baseball bat and you spin and spin and spin and spin and spin and spin, and it gives you the feeling of being drunk. Is that because your equilibrium's all messed up?
With that one, it's your inner ear. It's your semicircular canals, and then you may throw up even. This is just fine balance. It's just fine. That one is just, you're just
Picking
giving
everything up.
Yeah, the wrong signal. Okay. Next, we're going up. Now we go back to this picture. We're going to the diencephalon. So we studied this, the medulla. We studied the pons, the midbrain up here. Then we have the cerebellum. Now we're up here. This is the diencephalon. And the diencephalon has three parts: the thalamus, epithalamus, and hypothalamus. Okay? So, we're going to study the hypothalamus first. So, here's the thalamus, right here. This is the epithalamus over here. And this is the hypothalamus. So, this part, the hypothalamus you will encounter again when you come back for Bio 242. That's the first chapter for 242, which is the endocrine system. So this hypothalamus is the link between the endocrine and the nervous system. Have you heard of oxytocin or pitocin? So the hypothalamus makes that hormone, oxytocin, okay? An antidiuretic hormone, see? H for homeostasis. The hypothalamus is the major part of the brain for homeostasis. Look at what it has. It has the feeding center, the thirst center. It also has your thermostat. So It has, in other words, it has receptors for the level of sugar in the blood. When the blood that goes to my hypothalamus is low in sugar, it sends an impulse and you interpret that as hunger. You eat. Because neurons do not store sugar, remember? Right? So this is the key for maintaining homeostasis. Thirst is also important to life, right? So you see it has receptors for your for water balance also. Okay? Next, your epithalamus. That's the next one I want to study. The epithalamus, PI, right here, for pineal gland. That's where you find the pineal gland. And that is where the hormone melatonin is made. This is your sleeping hormone, isn't it? And it's secreted in increasing levels when it gets dark. So then we fall asleep. We get sleepy. So that's why it's called the sleeping hormone. I remember that there was a craze for melatonin. In the past, they say this is the secret to youth because it makes you fall asleep and you wake up refreshed. But then my dad took it and then he was wondering why he's sleepy when it's dangerous. You get sleepy when you're driving at work, you're just sleepy. It's your sleeping hormone, okay? So because of this, it establishes our circadian rhythm. At night we sleep, in the daytime we wake up. RAS wakes us up, okay? Next, thalamus. So next to thalamus, and here it is again, the thalamus is up here, okay? This one right here, over here. Next to thalamus, you're going to write relay station. So I'm going to use this one right here, and there's the thalamus, okay? And this is the cerebrum. This is the cerebrum. You see it has different colors because it has different areas of specialty, like vision goes here, hearing goes here in the yellow one. So the thalamus is like the receptionist. That's why you say relay center. It directs the sensation where it's supposed to go. Oh, are you a visual sensation? Go to the occipital lobe. Are you for hearing? Okay, then go to the temporal lobe. You understand? That's why it's called relay center. Another very important function of by the way, this nuclei, you won't be able to identify that. Okay? So when we're studying these different parts, I just want you to concentrate on the function part and just the key words that we're writing down. Okay? There's so much to the study of the brain. Neurology is just a lot and it's very dynamic. So when you go to over there, you're going to have more to learn. But now we're going to do the basic, okay? Next to thalamus, also write filter. Filter. Have you ever tried to study in an area where it's so noisy and yet you're able to concentrate? You were able to tune out all the other unnecessary information. Or maybe your husband is busy watching the Super Bowl and then you walk in, you're wearing your sexiest outfit. I didn't even see you, right? And then you're on the phone, you're talking to your girlfriends. He doesn't love me anymore. That's not true. Okay, at that point you were just not important to the game. So he was focused on the game. That's what it is. Because can you imagine? Do you feel your butt sitting on the chair? Now you do, because I told you. But earlier you didn't, right? Or your jacket. Now you feel it, but you didn't earlier. If we had to respond to every single information, you're going to go crazy. So that's what the thalamus does. It just filters the information that's necessary now. Okay? Okay. Now we're going up. We're going up. So the next one, I want you, the limbic lobe. See, we went up. So there was the medulla, the pons, there was the midbrain up here, then you have the thalamus, the diencephalon, the cerebellum was here. Now there is this lobe. You see, it says a functional lobe. The reason why they write functional is because there's really no anatomical boundary. In other words, there's still debate on as far as the anatomical location of this lobe, but everyone agrees that there is a limbic lobe. And next to limbic lobe, you're going to write memory. Memory, storage, and retrieval. That's the one. That's why you know your name. I still remember my telephone number when I was still living in the Philippines. That's because you have a limbic lobe. That's why you remember everything. You memorize and you remember. It's stored in here. You understand? Limbic lobe is also your emotional brain. So you become happy. You know how you go home, maybe you smell, they say, chocolate chip cookies, and then you start smiling because you just, all of a sudden you remember when you were a little child, maybe you were playing or whatever. That's because this is working in your brain, the limbic lobe. Okay, here, this is the cerebrum. This is the conscious part. Everything here is unconscious so far, right? So the last function of the limbic lobe is it links the conscious with the unconscious. See? Links conscious with unconscious, with the autonomic. Okay? Now we're ready to study the largest part of the brain, which is your cerebrum. This is the largest part of the brain. This is where the seat of intelligence is. Okay? The cerebrum. Before we look at the different lobes of the cerebrum, you know that there's two. You cut it in half. It's called the right hemisphere and the left hemisphere, right? So there's two of them. But before we study the different parts of the cerebrum, there's a few things we need to appreciate about the cerebrum. Number one, the right controls the left controls the right, right? Because of the crossing over of fibers. Number two, I know they look alike, but the function of the right is different from the function of the left. That's referred to as hemispheric lateralization or hemispheric dominance. I'm sure you've heard of people saying, you're just such a left brain individual, or you're so right brain. Look at the function of the right hemisphere. It's mainly for music, artistic talent, facial recognition, your emotions. That's why when a patient comes in, what do they ask? Don't they say, do you recognize this person with you? If you recognize, then maybe right brain is okay, then you go to the left. Look at the function of the left. This is for logic, for science, math, spoken and written language. So if a patient comes in, stroke, and then you know left brain is the one that's damaged. Then you go send for MRI of the left side, you see? Yes?
My grandmother, she had a stroke. She couldn't talk or articulate herself, but she could sing.
She can sing?
She could sing.
See?
She can sing music, like happy birthday to you. She can use her words. But then she tries to say, oh, you look beautiful. Nope, can't do it. She couldn't do it. It's exactly that.
Mm-hmm. It's amazing. But that's how you're able to figure out a plan. I'm going to look for left brain injury in this patient. Concentrate your MRI over here. It depends on the symptoms of the patient, okay? Don't forget the difference between right brain and left brain. I like to ask that in your lab exam. So in the lab exam, usually there will be one. The lab exam, the last lab exam is a little bit, it's a little bit, because you have your muscles and the rest of the nervous tissue. So there'll be one tray. In the past, usually I'll have a brain like this, and then I'll say, identify this whole structure. You're going to write this. I'll cut out everything. What will be left is just the cerebrum. So you're just gonna write, this is the cerebrum. So, and then I'll say, what side is this, right or left? If you write left, I don't know, whatever we put in there. You say left maybe. So I'll say, what do you think, can you give me one specific symptom that, and don't write problems on the opposite side. That's very, very big. People write problems on the opposite side to be safe. I just want to know left brain versus right brain. I want to know that you remember. Right is for facial recognition, artistic. I'm not musical. I'm not very. You come to my house is. I don't have any artistic talent. Okay. The left is for reasoning, science, etc. Don't forget this too. Now we're ready to look at. We're going to cut the brain. When you cut the brain, you will see that it has a white matter and a gray matter. So the gray is the cortex. The cortex is always the outer part, and it's gray. And now you know what makes it gray, right? What makes it gray is what part of the neuron? Cell body, very good. So let's picture this one. So you have lots and lots. Remember, the cell body is big, and then see, you can gather, you can have millions and millions of cell bodies up there, but the white, the axon, the reason it's white is most of the axons are myelinated, and myelin is light. It's mainly fat. So you know you can have millions of balloons and just hold them with your hand like that. And that's the problem. How do you think you're able to accommodate all of those cell bodies? And this is, you cannot expand your skull, so you fold, see? And these folds of the cerebrum, you call that gyrus. And the groove is called a sulcus. A deeper groove is called a fissure. So this one right in the center is very deep, that separates the right and the left. You call that a fissure. So right here, see? There's your gyrus, the fold, and then the groove is called a fissure if it's not that deep. The deeper one is called, sulcus, and the deeper one is called fissure. Okay? So let's look at now the different parts, the function of the different parts of the cerebrum. So I'm going to use this one right here. You see, just like our model right here, it's colored to let us know that they have specific function. That's why the thalamus has to direct the information where it's supposed to go. Okay? So the cerebrum is divided or separated into what you call lobes. Oh, before we look at these lobes, I forgot. Let's look at what makes up the white matter first. So this white matter, what makes it up are the axons, right? So this is where you see. And the axons, you see the axons, some of them going from here to the next, here to the next. You see that? And some of the axons projecting all the way down. And some of those axons are on their way to connect to the other hemisphere. And that's why the right and the left, they communicate with each other. Okay? So, depending on the direction of those axons, they form what you call fibers or tracts. They can either be called fibers or tracts. And there's 3 of them. So, the first is called projection fibers. Like this projector, you see? The light projects from there all the way down, right? That's the same thing here. The projection fibers are the fibers that go all the way down and then come out. The nerves that we're familiar with, your axillary nerve, the mid, that's the projection fibers. You understand? Okay? What about your commissural? Commissural. Commissural, for me, I try to communicate. it lets the right and left communicate with each other. So that's the one that connects the right with the left. You understand? Commissural, communicate between the right and the left. And then finally, the association. You know the homeowners association, right? It's just only among the homeowners. So here, so that's the association. They communicate, one gyrus communicates with the next, with the next, with the next, within the same hemisphere. So the association, you don't go to the next association. I hope that will help you remember. Projector, the projection, you project all the way down. Commissural, you communicate right to the left. And then association, it's just within the homeowners association, so within the same lobe. Now let's look at the cortex, and it's separated into lobes because they have specific function right here. So here, look at this, frontal lobe. From now on, as far as the nervous system is concerned, you should know that everything frontal, even the spinal cord, everything frontal is motor in function. In other words, if you had a stroke and it affected the frontal lobe, your problem will be paralysis. You can't move. You'll be paralyzed. You can't talk. Paralysis. Okay? And then posterior to the frontal is what you call the parietal lobe. Parietal lobe. Next to parietal lobe, you're going to write sensory. Somatosensory, by the way. Meaning, this is your seat of awareness, right? And so, we're only talking about skeletal muscle. All the unconscious part was from the diencephalon, the brainstem. This is all conscious. We're aware of this one. Okay, so somatosensory. Example, maybe touch, tickle, right? Temperature, I feel hot. That's this one. You understand? Okay? In the parietal lobe, somatosensory. So this is somatic motor, the frontal. Parietal lobe is somatosensory. Next, next to parietal, also write taste. Taste also goes to the parietal lobe. Then you have this temporal lobe, see? And you write it with a capital T like this, so that you have the earrings on each side over there, and this is your nose, see? Because the temporal lobe is where hearing and smell goes. Whatever will help you remember, but that's where hearing and smell goes. And here, your temples, right? That's where the temporal lobe is. So if you have a problem there, you may have problems with hearing or smell. Then your occipital lobe in the back of your eye, hopefully you remember, vision. That's for vision. What's that with the eye in the back? Is that the cyclops there? Some people have an eye in the back. They say,
Those are mothers.
That's your mom.
oh, that's
The
your
eyes in the
mom?
back of her head.
Oh.
She can always see what you're doing.
Oh, okay. So your mom, when you see your mom, that's the occipital lobe, okay? So for vision. And then there's another lobe. Another lobe called the insula. The insula, and I'll show you on Tuesday. So this is your temporal lobe. What you're going to do on Tuesday, you're going to pull this, and you see the insula hidden inside, under the temporal lobe, in there. And next to insula, write taste. Taste also goes there. Okay? So, I want you to look at this one right here. Do you notice, look at this one. It says primary, and then there's a premotor area here. Primary, and then association. There's primary and then association. In other words, in every lobe, there's always surrounding it the association area. Like when I write Okay? So your primary visual area will see characters. The association area is telling me, oh, I see letters. You understand? So when that stimulus hits my primary visual area, I see characters. The association area is telling me those characters are letters. Then you see this common integrative area. That's the one that integrates everything. Oh, free spaghetti in room 25. So I get up and go to room 25. You understand? It's just like sound. When you hear sound that goes to the primary auditory area. The association area, the auditory association area is telling me, oh, it's a person. I hear a person calling me. The integrative center tells me, oh, it's Lily calling me. So I get up and go. If it's my husband calling me, I ignore. You see? That is the integrate. You understand? That's the importance of the association area. So and then the premotor area, in other words, the premotor area contains the recipe of every muscle group that you need. So this is what happens. Let's say my daughter is calling me. So the association the main area, the primary area tells me I hear a sound. The association area tells me it's the sound of an individual. Integrative will tell me it's my daughter calling me. Then I have to go to the premotor area for the list of muscles that will be needed so I can talk and say, yes, wait a minute. Then go to the primary motor area. Where's the primary motor area? The frontal lobe, right here. Primary motor area, right there. That one then will go innervate the muscles of my mouth so I can say, yes, wait a minute. Or innervate my leg muscles so I can get up and walk. You understand? Okay? So this table here, the next tables or slides, is just showing you the difference between the primary and the association area. So what we have studied is just the basic neurology. Like I said, it constantly changes. Not change, but there's always something that they add to the study of neurology. Maybe when the new edition comes out, there will be an update to that. But so far, that is what we've learned. It's basic. This one doesn't change. Okay? You understand? And I'm sure you've heard of EEG, how now you know that the nervous system consists of neurons, and neurons always fire an electrical impulse. And so to assess the health of the brain, we can send the patient for EEG. And these are typical waves. If you are asleep, you're awake but you're resting, this is what you should be showing, alpha waves. If you're awake, you're not doing anything, and then you have this or this, then you know that there is a pathology. So you have to send maybe for MRI, right? Beta waves, if you're you're physically active or you're concentrating. This one should only be found in children. This one is if you're in a deep sleep. This one I don't really require you to know, but I'm just showing you so that you understand that this is one of the basic tests that they can request to find out if your brain is normal or not. So the last part of this chapter talks about your cranial nerves. Do you have any questions so far? No questions? Okay. So as far as the cranial nerves are concerned, this is how I want you to write them. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 11. And then next to that, you write SS, MM, BM, BS, BB, and M. S for mainly sensory or purely sensory. So in other words, cranial nerve number 1 is a purely sensory nerve. If you damage cranial nerve number 1, you will have no motor paralysis because it's only sensory. M is mainly motor. So if cranial nerve number 4 is damaged, will you have sensory problems? No, it's mainly motor. So it's paralysis. Okay? And then B for both sensory and motor. And then, how do I want you to study for these cranial nerves? You will study it in terms of how do you test for that. So cranial nerve number 1 is your olfactory. So how do you test for cranial nerve number 1?
Can you smell this?
Smell, yeah. So you put something and can you smell that? If they smell it, then it's working, right? Very easy. Cranial nerve number, you notice we didn't talk about number 1 and number 2 as far as origin in the brain. Cranial nerve number 1 sits on the base of the frontal lobe. So sometimes, like boxing or people who have severe head trauma, right here, after a while they'll complain of problems with smell. That's because it's right here, okay? And then cranial nerve number 2 is your optic nerve. It's right here. It's at the base, close to the frontal lobe, up there. So, optic nerve is purely sensory. How do you test for optic nerve? Cranial nerve number 2. Can you see? Right? If you can't see, then you know that they have a problem with cranial nerve number 2. Okay, cranial nerve number 3, 4, and 6. These nerves move the muscles of the eyeball. So they move the eyeball. That's why you're able to, especially with the guys, right? These 3 cranial nerves with the guys are the ones that they use the most. When they're walking with their girlfriends, they don't want the girlfriends to notice that they're looking at someone else like that. See? You see? It works for them, right? Okay, so cranial nerve number 3 is your oculomotor nerve. In addition to moving your eyeballs, this is the one that constricts your pupils. So you use your pen light and you shine a light on the pupils, and it controls pupillary constriction, light reflex. So what should happen if you shine a light? It constrict, right? And then in the dark, it should dilate. So if you shine a light and nothing happens, cranial nerve number 3 is damaged. And then you're going to trace, where is this one coming out of? The midbrain. So you're going to suspect midbrain damage. This is why this cranial nerve tests is very important. It's so easy to do cranial nerve testing. It's very hard to go do testing of the brain. So at least this is preliminary, and it gives you an idea of where to send the patient next. Okay? Cranial nerve number 4 also moves the eyeball. Okay? And what you're going to do, this moves you say to the patient, follow this pen moving down. It innervates the superior oblique muscles that helps you to move your eyeballs down and inward. So, look, follow this pen without moving your head. If you're able to see it, then you know this cranial nerve number 4 is working. And then we're going to jump to cranial nerve number 6 first, which is your abducens nerve. This is the one that innervates your lateral rectus muscle. So you say, follow my pen moving side to side like this without moving your head. If you're able to see that pen, cranial nerve number 6 is working. You understand? Okay? Now we go to cranial nerve number 5, which is your trigeminal nerve. This one, see, number 5 is both sensory and motor. It's the one that detects sensations to the face. So you can pinch, right? They say, ouch! Oh, good. I was just testing your cranial nerve number 5. So by the way, right and left, right? There's 2 sides. Or you can put something hot, something cold. And then what about the motor part? It's the one that is responsible for chewing, the muscles of mastication. So you can tell the patient, can you clench your teeth? If they're able to do that, you see the muscle being strained over here, you know that that cranial nerve is working, okay? Then we go to cranial nerve number 7 is your facial nerve. So 7, 9, and 10, these 3 cranial nerves are the ones for taste. And they're the ones for taste and
7, 9,
7, 9, and 10 are for taste, okay? And if you have a problem with 7, 9, and taste, one common complaint will be loss of taste, of course, and also dry mouth. They're the ones that make saliva, 7, 9, and 10. So a patient comes in, dry mouth, think 7, 9, 10. How do you test for cranial nerve number 7? Let's look at this one. It's both sensory and motor. The sensory part is for taste. That's the sensory part. And then the motor part, face for facial expression. The facial nerve, which is cranial nerve number 7, this is your facial nerve. That's the one for facial expression. So you say, can you smile for me? And if the patient is able to smile, you know that this is working. You know that there's a right and a left. So when they smile, you should look for symmetry. Okay. A common problem with facial nerve injury, Bell's palsy. You know that, right? Where there's paralysis. So my cousin, the day, 1 week, I think a few days before she was going to get married, she woke up with severe Bell's palsy. So she told her fiance, you don't need to marry me anymore but they've been married for almost 30 years now. But and you can still see a little bit. It took a long time for that Bell's palsy to heal. Yes.
Why was it damaged? Like,
you know, no one really knows why it gets damaged. In the Philippines, we have a lot of those cases of Bell's palsy, and it's because of they say the electric fan. It's hot there, and so a lot of people sleep with that fan right there to their face, and I think it paralyzes the facial nerve, and so they wake up with Bell's palsy. But as far as a specific cause, they don't. Next, cranial nerve number 8, vestibulocochlear nerve. So purely sensory, if this gets damaged, will you have motor problems, paralysis? No, only sensory. So this is for hearing and balance, equilibrium. So the one, Stacy, you were saying that's the one, see? So how do you test for cranial nerve number 8? Can you hear me? If you can hear me, that's working. There's 2 components. And then the other one for equilibrium. So you have the patient stand on one leg. Can you do that? Then go to the other one, because there's both, they're paired, right? One at the right, one at the left. If they can do that, then that cranial nerve is working. Now we go to cranial nerve number 9, which is your glossopharyngeal nerve. So it's both sensory and motor. So that's for taste also. Then G for gag. You know, they take a tongue depressor and they make you gag. And then when you gag, they say, okay, good. Because they're testing for that cranial nerve. Okay? Next, cranial nerve number 10 is your vagus nerve. Vagus nerve. And this also for taste. 7, 9, and 10 are for taste. But how do you know for cranial nerve? How do you test specifically for cranial nerve? That's the one, V for voice box. So this is the one also for your voice, responsible for your voice. So you say to the patient, open your mouth and say, ah. Then you look at the uvula. Are you familiar with the uvula, everybody? The uvula should be in the center. If it's pushed to the side, must be the opposite cranial nerve is a problem. Okay? So, but V for voice box. Cranial nerve number 11 is your Oh, number 11 is your spinal accessory nerve. This is the one that moves. It's motor only. So the muscles of the neck, so you're able to go like this or like that. And this part right here, you say to the patient, raise your shoulders against pressure. So you put pressure down, and if they're able to raise both right and left, okay? If they're able to do that, you know that this is working. See the muscles? Trapezius. Okay? Then finally, hypoglossal nerve is motor. Don't forget this one, okay? Is it only sensory, only motor? Because I like to ask that in the test. Will there also be paralysis? No. You're going to say no because it's only a sensory. Will there be paralysis here? Oh yes, because this is a motor. So this hypoglossal is the one that moves your tongue. You know your tongue is also important for talking, for speech. But what is the test that's specific for cranial nerve number 10? Stick your tongue out. And when you stick out your tongue, it should be in the center, not moving to the... You see some patients to the right or to the left, you know that's the damaged nerve. Okay? So again, why do we ask you to do this cranial nerve testing? Because it's so easy to do. And it tells us where in the brain is the problem. Because all these cranial nerves come out of a specific part of the brain. Remember, I had you write that down. 8, 9, 10, 11, 12 comes out of your medulla. So if there's a problem with any of those nerves, then I think, oh, I'm going to look at the heart and the breathing too, because that's the medulla. You see? Okay? You understand? And so your lecture test next Thursday will be chapter 11 and 12. Okay? On Tuesday, we're going to start with chapter 13, and then we're going to finish up, not finish up, we're going to you do your dissection for your muscles, and then the brain. I'm going to borrow one cat from you, whoever wants to lend me your cat, and I'm going to cut the muscles to show you the muscles on Tuesday. So, or I can use any other cat that's there. Okay? So, that's it. Yes, 5 to 8. It's like the 8 is, part of it comes from the pons and part of it comes from the medulla. By the way, Sarah, that's the one. One is over here, you see? One is just at the base. You see it.
Oh, I see, okay.
And 2 is over there too. So they don't
In
come
the
out.
cerebellum?
No, right here, the base of the frontal lobe.
Okay,
So they don't come out of a specific.
which is
Okay.
what, okay, 1 and 2, cerebellum.
Okay.
Or no, cerebrum.
Enjoy your weekend, okay? Yes, yes. Is this you?
Yeah, there are pairs. They're all paired.
Okay. Are you?
you over to see that view?
Okay, so it's right there.